In a previous segment on lock bumping, we talked about several things, including the theory, and we showed one or two locks being bumped. This segment is going to go into a little bit more depth and pick up where the first segment left off. Basically, what we said in the first segment is that you can bump a pin stack, but sometimes you have something else stopping the plug from turning, some secondary locking device. And so what we're going to do in this video is talk about how we can use bumping in conjunction with other techniques to open high security locks. Before we get into that, though, I would like to, if I can, just review for a moment the theory of bumping. Different people explain it differently. I like to explain it this way. It's a model. It's not exactly how it works, but it gives you an idea. If one was to take one of these balls and pull it out, you'll notice that this ball over here moves. The rest of the balls do not. Now that's not totally true. You can see some movement in those three in the middle. Some people have done some high-speed photography and found that maybe the entire pin stack goes up and comes down, but the point is the top pin is always lagging. There's always this break in between. So that's what allows bumping to happen. And we've showed bumping before, like this is on a master padlock, and what we do is we pull the key out just a little bit, turn, and like so, the lock will be open. We could do the same thing on a Schlage lock. Simply pull the key out a bit and just tap it, and the lock turns open. Fairly simple procedure. What do we need to do this? Well, we need a bump key, and we need some type of hammer device. This is just simply a plastic mallet that one can buy in any hardware store. Works fine. These are actual bump hammers. They're produced by various companies and so forth. They all work. It really is a little dependent on the lock which one works best. This is the old method of bumping, where we're actually pulling out the key. That's called the pull method. There's also a push method, and the push method is when the key, when the pin itself pushes down here and pushes out the key. I'll show that to you on this lock, and it may be a little difficult to see. Can you see that key pulling out? If not, we'll take a macro shot of it later. But basically, it's being pushed out. So the procedure here, and I'll explain what I'm doing in detail later, but I'm just getting this thing ready so that I can bump the lock open. Now what makes this especially interesting is this is a Medeco biaxial lock, which means it has that secondary locking device. So did I just bump this lock open? Well, yes and no. I bumped it, but I used another technique to defeat the sidebar. So it's bumping used in conjunction with another technique. Now, as far as offsetting the cuts, this can be done when you take a bump key and make it, and you basically either bring the shoulder back a little bit, or you offset it in your key cutting machine. And because that shoulder is back a little bit, this pin is going to hit just on the beginning of this ramp and tend to push that key out slightly. So that's a good thing to do on any bump key, really. And the reason is this. One of the biggest problems we've had with bumping is that a lock with long pins, in other words, very deep cuts, what would happen is as you push that bump key in, you are raising that bottom pin above the shear line, and therefore it's never going to bump. So that becomes a problem. However, with the push method, that ramp, that tip in between the two cuts never goes past the pin, so we don't have to worry about long pins. So that's good whether we're bumping a simple master or Schlage, or whether we're bumping a high security lock like a Medeco. So that's how the bumping part works. But how are we overcoming the sidebar? Well, we're overcoming the sidebar, in this case, with the bump key. This is a special key, and the way that it works basically is it has pretty much all of the deepest depths that are possible on this key, but it also has the angles that are necessary. So in other words, if we know the sidebar code, in other words, we know what the angles are, then we can build a bump key that has those angles already included in it. So now, when we're bumping that lock open, we basically already have the sidebar set. To set the sidebar, what I'm doing is I'm turning this counterclockwise, and we're seeing a little bit when we get another training aid up here why I'm going counterclockwise. But as I'm going counterclockwise like this, what I'm doing is I'm causing those pins that are now at the proper angle, I'm causing a little bit of pressure on those pins, and the pins are not at the shear line, but the true gates are aligned with the legs of the sidebar at this point. And by putting a little pressure on, I'm actually forcing those legs into the true gate. Now I can relieve that pressure just slightly, and what's going to happen is those pins can't rotate because those legs of a sidebar are in the true gate. If I hold extreme pressure on there like this and try and bump it, the pins won't move, so I can't bump. But I have to have enough pressure so that those legs of the sidebar remain in the true gates. Now, when I apply pressure here and bump, the lock can open. All right, the question now is, how do I know the angles? You know, that's fair enough, we can bump it, but if I don't know the angles, what good does it do? Well, there are two situations where we might want to bump open a lock, and only two, really. One is where we have a master key system, and one is where we have a unique key, in other words, a lock that's keyed different, not part of a system. What I want to talk about now is how we handle the lock that is in the master key system. In a Medeco master key system, we already know what the angles are for every key in the system, because every key in the system has the same angles. Now, like everything else, there's exceptions to every rule, and there's some very, very large systems that use double cuts where it may be a little bit more difficult, but still possible to figure out what the angles are. This type of information, which is really beyond the scope of this video, can be found in LockSafe and Security International Police Reference. It talks very much about how that's done, and particularly the high security supplement to that. Many videos and so forth that go into much more depth. But suffice it to say, for this video, we know the angles because we have access to a key in the system. And the covert entry people would call this a sample lock. It's not the target, the one that we want to enter, but we have a sample lock. Well, if we have a sample lock, in other words, a lock out of that system, any of the master keys, any of the change keys are going to have the same angles. So then we cut our bump key from that with those angles, and basically with the deepest depths. Now there's a little exception to deepest depths too, and we'll talk about that in a moment. But once we've done that, we can now bump a Medeco that is a part of a master key system. So that brings up the question, what about the key different lock? What about that unique lock? Can we bump it without knowing the angles? Well, no. We'd have to make so many bump keys that it just wouldn't be practical. I mean, if we had every possible angle, we could do it, but how many keys would that be? Well, it turns out it's not that many keys. Why? Well, because, first of all, key different locks in the Medeco system use only the angle codes that Medeco wants you to use for key different locks. Well, why do they segregate the angle codes for key different locks and master key locks? Well, very simple. Key Records Department reserves things to be used for various uses. For example, top master keys may be reserved so that those cuts are never used anywhere else in a master key system. Control keys for interchangeable cores may be reserved so they're never used anywhere in the system. So that you can't find other systems that will have your TMK or have your control and so forth. Well, in the same manner, the Key Records Department at Medeco reserves key different codes so that you can't go to a locksmith in your city and buy a lock and a key and have that key be, say, a master key for some master key system also in that city. So they control it, and they publish a book. And medical dealers have the book, and there's a limited number of codes in that book, 700 and some odd codes, that can be used for key different locks. So, knowing that, an analysis can be done of those codes. Once you do the analysis of those codes, there are several tricks that you can do to reduce the number of keys you need. So you don't just need 700 and some odd. Again, it would be too big. It'd be unmanageable. So what can we do? Well, first of all, let's say in this particular key we have a 6-pin tumbler lock. 1, 2, 3, 4, 5, or a 5-pin tumbler lock. It doesn't matter. How many cuts do we have in the key? Well, normally for a 5-pin tumbler lock, we have 5 cuts. For a 6-pin tumbler lock, we would have 6 cuts. So it's a question of the same number of cuts to the same number of pins in the lock. Except, remember what I said a few moments ago, that it's possible in complex master key systems to double cut. That means have both a fore and an aft cut in each pin position. Okay, with a fore and an aft cut in each pin position, what that winds up doing for us is basically doubling in each position the possible angle codes. So in master key theory, we know the formula to figure that out. We take 2 times 2 times 2 times 2 times 2 times 2, which is 64. So one key, if it were to be double cut in all of the space positions, now I've got 12 cuts instead of 6 cuts, one key could open 64 different angle cuts. But there's more. There's another trick that we can use. And that is, this gets a little complicated. Again, I'd refer you to the Lock, Safe, and Security International Police Reference book on, well, it's on about everything in locksmithing, really. It's but the chapter on master key covers Medeco. Medeco master keying is really, particularly in the biaxial, is difficult for many locksmiths. In fact, I don't believe Medeco even recommends that the locksmith develop master key codes. Why do companies come out with improvements in locks? Well, there are several reasons. One, they may be trying to extend a patent. Two, they may be trying to improve security. Or three, they may be trying to improve the functionality of the lock. In the case of Medeco, when they came out with the biaxial system, they were trying to increase one of the functions of the lock, and that is master keying. Trying to make larger and larger master key systems by having both a fore and an aft position to have their 3 angles of cut. This would give them a very huge capability in a master key system, except there was a problem. And the problem was an aft cut on, say, pin number 1 and a fore cut on pin number 2, if it was the proper angles, either one, the cut on pin 1 or the cut on pin 2, could set a pin at the proper position. So there were real problems in interchange. In other words, keys that weren't designed to open a particular lock in the system, opening that lock. So what Medeco had to do is go through and figure out how those interchanges worked, and then not allow certain fore cuts to be next to certain aft cuts. And again, as I say, the LSS book or the video explains that very much in detail. Well, we're going to take advantage of that problem in that, because we are cutting both fore and aft cuts in each of the 6 positions, in other words 12 cuts, each key will handle more than 64 cuts. Actually, it turns out that for the standard biaxial lock that came out, that had the code book for years, it only takes 4 keys. Those 4 keys, one of those will handle any particular cut. Now, I don't know which one it is, so I'd have to try all 4. But that's not, that's not all that difficult. Again, put the key in, you notice it pushes it out. And I'm going to try and set that sidebar, and we'll talk more about that later. And once I do, let's see if we can get this thing to bump. This may not be the right key. Try a different one. There we go. That was the right one. So, you know, I don't want to give you the impression that this is an easy thing to do. It's not. Medeco is a very, very good lock. I use it myself. But you know, it's not infallible. It can be bumped, and a key different lock can be bumped using this technique. I'm going to now well, let's not do that. Let's do this. Let's talk a little bit about a newer lock. Not the biaxial, but the M3 lock. I'm just going to cover that, not in too much detail, but basically the M3 lock has a slider in it. We could bring a sample of that's a cutaway and do some macro shots later on it to show you what that slider looks like. But at any rate, it's a third element. So we said on the original bumping video that we can bump a standard pin tumbler lock. We can also bump open a lock that has a secondary locking device if we can figure out a way to defeat that. We've done that with the Medeco. But we may have a third type of device, and the slider's a third type of device. Well, that also can be defeated. In fact, because all the sliders are the same length, it can be defeated with a simple wire inserted in the front of the lock. When Medeco went to the M3 with the slider, of course, they had to do some side millings on their keys to operate the slider. The effect of that was to widen the keyway. Well, that lock can be bumped as well, and here's you know, any improvement you make maybe leaves open another method of attack, and in this particular case it may make it just a little bit easier on the M3 than on the biaxial. And the reason is an M3 that basically has biaxial keying in it has a wider keyway. You see, I could not use a bump key for this lock in this lock unless both locks had the same keyway. But because of the width of the M3, what we can do is use a flat key like this, and it'll fit. Again, there's only 4 keys in this set, but there's 8 keys here. The reason there's 8 keys is we have both a 5-pin and a 6-pin, just like here we demonstrate on a 5-pin and 6-pin. But the point is, I only need one set of bump keys, bump or set keys. Let me explain the set keys in a moment. But one set of bump keys for a 6-pin tumbler biaxial keyed M3 lock, and of course the wire to defeat the slider, and that can be done. Where with the biaxial, now all I have to do is have a different set of bump keys for each keyway. So it's a little bit easier. If you want to go back before the biaxial, the original product Medeco, because it did not have the chisel point pins, would take many, many more keys to bump if we did not know the angle. Of course, if we know the angle, it's not a problem if it's a master key system. So really, as they have improved their lock over the years, they've made it more susceptible to bumping. Still not as easy to do as with this lock, but certainly possible to do. Okay, I also mentioned that these could be called set keys as opposed to bump keys. Well, you know, really, what I'm doing with this lock, when I put this key in, and I'm turning it and put turning pressure and getting those legs into those pins, what I'm really doing is trapping those pins from rotating because the legs of the sidebar are in the true gates of the pin. Now think about it. If I were to put pressure on this plug so it maintained that torque, just like you would with a tension wrench, if I were to pull this key out at this point, what's happening is those pins are going up and down, but they're not rotating. So I have set the angle. So I could use basically a bump key, or any key for that matter, that was cut to the right angles, like the wrong key in a master key system, in other words, a key that had the proper angles but not the proper depths. I could then set this cylinder. Now I can let go here, and I don't have the torque, but there's been nothing to turn those pins, so they're set at the proper angles. Hence the terminology set key. Now I can put a tension wrench in here and pick that lock like I would any normal lock. So although this video is on bumping, not picking, the same principle can be applied to pick the lock. Now it's a little bit more difficult to cut the biaxial keys, bump keys, than what I have described. First of all, you've got to do the math and figure out what those 4 sets of angle cuts are. We also use another trick that I didn't mention. I should have. We use something called compound angles. The normal Medeco cut is at 30 degrees. We've gone halfway between that at 15 degrees. I didn't mention that earlier. But again, that's one of the reasons, one of many reasons why we've been able to reduce this down to 4 as opposed to 700 and some odd keys to do the job. But there's another problem as well. And that problem is because we are using 12 cuts instead of 6 cuts on the key, the cuts are closer together. And think about just normal locksmithing. What happens when cuts are close together? Well, we have a MAC violation. In other words, to make one cut, we have to cut away part of another cut. So that would happen if we were to make one of these keys. So how do we make the key and not do that? Well, not only do we use those compound angles of 15 degrees, but we use compound depths. In other words, the 4 cuts are at a different depth than the aft cut, which gets away from the MAC problem. So again, I'm not trying to say this is easy to do, but I am trying to say it's doable. Now I would like to switch to another camera shot and show you inside of a training aid, just one cylinder of a Medeco, or one chamber rather, of a Medeco cylinder, how these pins get set at the proper angle. Okay, what you see on the screen now is a mock-up of one chamber of a Medeco biaxial cylinder. And this, of course, is the bottom pin, and we also have a top pin and a spring. We have a plug, and we have a sidebar, and the sidebar has a leg on it. And this is a false gate, and right behind here is a true gate. Now we have false gates and true gates on the left angle and the right angle. The center pin does not have a false gate, the center where there's no angle basically. And as I say, we can lift this up to the shear line and turn, and as long as the rotation of the pin is correct, this will turn. Of course, we've got maybe 5 more chambers that might stop it from turning, but with the correct key in there, working on this chisel point, it will turn it to the proper place. If it's not turned to the proper place, even though I'm at the shear line, I cannot rotate the plug. So what I would like to show is if I rotate this so that the true gate is where it's supposed to be, and then I put inward pressure here, now I cannot rotate that pin. And the reason I cannot rotate that pin is because the leg of the sidebar is in this true gate. So now if I were to lift this up to the wrong angle and then let it drop and take my key out but maintain that torque, now this pin has not rotated and it's at the proper angle. Now it's just a matter of taking my pick and lifting up to the proper point, and I have set the sidebar. That's what I mean by setting the sidebar. Now it's also true that I could rotate this plug counterclockwise, and you can see the movement there, I believe, or clockwise. Counterclockwise, you can see there's more movement than clockwise. Doesn't mean it's impossible to do this clockwise, it just means it's more difficult because the leg does not go into a true gate as far as it does here. So that's why we always bump or pick counterclockwise. Now it is possible, of course, that we need to go the opposite direction. But then, of course, we can use a plug spinner like we would on a normal plug once we have the pins to the shear line. So that is basically how this works. And what I would like to do now is switch to a different model and show you how those half cuts, those compound angles work. You recall I mentioned the angles. I don't remember what degree I used, 30 and 15 or 20 and 10 or whatever the actual angles are. Like I say, the true place that you want to go if you want to know exactly what these angles are and cuts and so forth, you want to go either to the High Security Supplement of Lock Safe Security International Police Reference, or you want to go to the book that supplement is from, and that book is open in 30 minutes, and that has the exact angles. I believe it's actually 20 and 10. But the point is, well, and I say you want to go to the book. You can buy the book if you want to. It's much more expensive to buy the entire LSS and the high security sup than it is just to buy the book. The book's fairly inexpensive. But what you don't have in the book and you have in the high security sup is quite a few videos like what I'm doing, but in much more detail, and charts that tend to show you which of those 4 keys you can use. That's just by looking at the first 2 pins and illustrations and so forth. So if you really want to get into this in detail, it's much more than what we can do here in a one-day class or a one-day video. There's hours and hours and hours of videos and charts and so forth in there. But the point is, I'm now going to go to a different view of this pin right here. A view from the top of this pin with another mock-up. So we'll switch to a different camera shot now and do that. Okay, we've now switched shots, and by the way, I mentioned the name of that book that's kind of a, well, not just on Medeco, but a lot of high security locks, is tremendous reference books. But I kind of had the wrong name, and Mark, the guy that wrote the book, or one of the guys that wrote the book, corrected me since he's shooting these videos. I said open in 30 minutes. It's actually open in 30 seconds.
There's actually quite a difference.
Yes, that's what he says. However, I take exception with him. I think it's wrong. I think you saw me bump them open in less than 3 seconds, but then, one could argue that all day long, but it certainly is a lot shorter than 30 minutes.
We were trying to be kind, Harry.
Yes, I understand. Well, at any rate...
And Harry, let me make one other correction, so you don't forget that we talked about in the interim. The four code setting keys, there is a matrix in the book that we can tell which one or more of the 4 keys to use based on a visual external inspection of the first 2 pins in the keyway.
Yes. I think I mentioned that a minute ago that if you want to get really in depth, you've got to get to that reference. But at any rate, what we're trying to do here is just show the principles and show one more thing, and that's going to be our grand finale here in a moment. But let's do this. This is the top of the pins that we're looking at, and we can have a left of center or a right of center pin. Or we can have a center pin, and a center pin means there's no angle. So what we're concerned about is not a center cut, whether it be fore or aft. What we're concerned about is a left or a right cut fore or aft, because that's where our compound angles come in. So let me just pick this one and set it up on this mock-up. And what we have here, this would be it's not real, I mean this is just a mock-up, but this is a representation, you might say, of the leg of the sidebar, and this is a representation of the true gate, and this is a representation of the false gate. And as you can see, when we go in the false gate, we don't go in far enough that the sidebar is out of the way where the plug can rotate. But when we go in the true gate, we're okay. And we have a tab over here, and that tab limits the rotation. And that's what you see when you look basically at the top of a Medeco pin. Now, if I were to go halfway between here and push in, what's going to happen is it's going to find the true gate. So by using that angle a little bit off of the actual angle, let's say it's 20 degrees approximately, doesn't matter. If I'm in the center of that, about 10 degrees, and I push in, as you can see with this model, what's actually happening is it's finding that true gate. And that's why the compound angles work. So it's a rather complex thing. Okay, so what have we learned here today? Well, we certainly haven't learned in detail everything there is to know about picking or bumping high security locks, but I believe we've learned one thing. And if we only learn that out of this video, I think it's important to the locksmith. This is a safe lock that you have seen before on another segment. And I just want to show you one thing on this lock, and that's this label on the back. It says manipulation proof. Well, that other video segment that we have shows how to manipulate this lock. The manufacturer may have felt it was manipulation proof when the lock was introduced to the market. But as far as I am concerned, there is no such thing as pick proof, bump proof, or manipulation proof. Because someday someone is going to figure out how to do it. So, you know, if there is no other lesson to be learned from this video, the one lesson that I believe we should all learn for liability purposes and to protect our customer is never sell a lock as bump-proof, pick-proof, or manipulation-proof. Because it probably isn't. Probably someday someone's going to figure out how to defeat the lock using one of those techniques. Now, we've only talked about Medeco on this video, but if you're interested in other high security locks, again, the LSS book and the high security sub to it, they open in 30 seconds, or the actual video of that book with the DVD that comes with the book on it as well as the videos, goes into detail of how to bump other high security locks such as the ASA, such as the multi-lock, and so forth. So the main thing we want to show you is that bumping is real, it works, it's very effective. There are new techniques in bumping, like, for example, the push key. High security locks that have secondary locking mechanisms are also susceptible to that attack.